A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
I was thinking about something today that I know is going to get you fired up. I was looking at a set of database credentials and I thought, why am I writing all this code to fetch a user profile? Why do we have this massive, complex industry built around middleman layers? Today's prompt from Daniel is about the history of APIs, the divide between REST and GraphQL, and how all of this fits into the new world of the Model Context Protocol. But before we get into the technical weeds, I want to start with the fundamental question. Why can't I just give an artificial intelligence agent the password to my Postgres database and say, hey, go nuts?
Herman Poppleberry here, and man, you are speaking my language. That idea of the database as an API is the ultimate developer siren song. It sounds so efficient, right? You cut out the middleman, you remove the latency of an application server, and you let the client just query the data they need. But the reason we don't do that, and the reason APIs exist in the first place, comes down to three things: security, stability, and semantics. If you give a client, or especially an autonomous agent, direct access to your database, you have effectively handed them the keys to the kingdom with no guardrails. You are essentially saying, I trust this model to not only understand my data, but to respect the implicit business rules that aren't actually written down in the schema.
But we have row-level security now. We have complex access control lists inside the database itself. Projects like PostgreSQL or Supabase have made it much easier to expose a database directly. Is it really just a security issue, or is there something about the way we structure information that requires that middleman?
It is much deeper than just security. Think about the contract. An API is a promise. When I build a REST API, and I tell you that hitting the /users endpoint will return a JSON object with a name and an email, I am creating a stable interface. I can change my database schema behind the scenes. I can rename the columns, I can move the data to a completely different type of database, or I can split one table into 5. As long as my API still returns that same JSON object, your code doesn't break. If you were querying the database directly, every single time I optimize my storage layer, your application would go up in flames. This is what we call the leaky abstraction problem. Without the API, the internal mess of your storage engine leaks out into the world.
So it is an abstraction layer that allows the backend and the front end to evolve at different speeds. That makes sense. It is like the steering wheel in a car. I don't care if the car has a rack and pinion system or electronic power steering. As long as I turn the wheel left and the car goes left, the interface is doing its job. But let's look at how that interface has changed. We went from these heavy XML-based protocols like SOAP and remote procedure calls to REST, which dominated for over a decade. Why did REST win so convincingly?
REST, which stands for Representational State Transfer, was defined by Roy Fielding in his doctoral dissertation back in the year 2000. It won because it leaned into the existing architecture of the Internet. It used HTTP verbs like GET, post, put, and delete to treat everything as a resource. It was simple, it was stateless, and it was human readable. You didn't need a special library to understand what was happening. You could just look at a URL and know exactly what you were requesting. It was a very American way of solving a problem, keep it decentralized, keep it standardized, and make it as easy as possible to build on top of. REST turned the web into a giant, queryable library of nouns.
But then we hit a wall. As our apps got more complex, we started running into the overfetching and underfetching problems. I remember when Facebook open-sourced GraphQL in 2015. The promise there was that we were moving from resources to graphs. Instead of hitting 5 different REST endpoints to get a user, their posts, and their followers, you could do it in one single query.
That was the massive shift. In a REST world, the server defines the shape of the data. You take what the server gives you. even if you only need the user's first name, and the server sends you their entire biography and 25 different metadata fields. That is overfetching. It wastes bandwidth and increases latency. Or, conversely, the server doesn't give you enough, so you have to make 3 more requests to get the related data. That is underfetching, and it leads to the waterfall problem, where your app is stuck waiting for sequential network calls. GraphQL flipped the script. It allowed the client to say, here is exactly the data I want, and here is how I want it shaped. It turned the API into a queryable graph where the relationships between data points are first-class citizens.
It feels like GraphQL is almost moving back toward that database, as an API dream, but with a safety layer in the middle. But here is where it gets interesting for our current era. We are now in a world where the primary consumer of these APIs is often not a human developer or a mobile app, but an LLM-based agent. When we talk about wrapping these interfaces in something like the Model Context Protocol, does one of these architectures have a leg up?
This is where the technical trade-offs get really spicy. If you are building an MCP server to expose tools to an agent, you have to think about how that agent sees the API. REST APIs usually rely on something like an Open API specification, which used to be called Swagger. It is basically a giant document that describes every endpoint, every parameter, and every possible response. The problem is that these documents are often massive, they are frequently out of date, and they can be very ambiguous for an AI to parse. An agent has to read through hundreds of lines of YAML or JSON just to figure out how to get a user's email address.
I have seen that firsthand. You give an agent a poorly documented REST API, and it just starts hallucinating parameters that don't exist because it is trying to guess how the developer's brain worked. It is like trying to navigate a city with a map that was drawn from memory by someone who lived there 10 years ago. It is inefficient and, frankly, dangerous if the agent starts trying to guess its way through a delete request.
Now, compare that to GraphQL. GraphQL has a built-in advantage here called introspection. Every GraphQL server is self-documenting by design. You can ask a GraphQL API, tell me everything you can do, and it will return a perfectly structured schema of every type, every query, and every mutation available. For an agent, that is like having a high-definition, real-time GPS map. It doesn't have to guess. It can look at the schema and say, okay, I see a user type, it has a field called email, and I can filter it by this specific ID. The token cost of discovery is much lower because the schema is so dense and structured.
So you are saying GraphQL is inherently more agent-readable because it is more strictly typed and self-describing?
In theory, yes, but there is a huge catch. GraphQL is much harder to implement correctly on the server side. You have to deal with the n+1 query problem. This happens when a single complex GraphQL query accidentally triggers hundreds of individual database lookups. For example, if an agent asks for 10 users and their last 5 comments, a naive GraphQL implementation might do one query for the users and then 10 separate queries for the comments. That can crash your system. REST is much easier to cache and much easier to rate limit. If an agent goes rogue and starts spamming a REST endpoint, I can shut that down in a second. If an agent writes a recursive, nested GraphQL query that asks for the followers of the followers of the followers of a million users, it can melt your database before your monitoring tools even wake up.
That is a terrifying thought for anyone running a production system. It sounds like the agentic friction we talked about in episode 1076, where the plumbing of these systems starts to fail under the weight of the automation. If we are building these MCP servers, we are essentially creating a translator. We are taking the language of the model and translating it into the language of the API. If the API is REST, the translator has to do a lot of work to explain the context. If the API is GraphQL, the translator just has to pass through the schema.
And that brings us to the interoperability question. The Model Context Protocol uses JSON RPC 2.0 as its transport layer. It doesn't actually care if the underlying source of truth is a REST API, a GraphQL server, or a flat text file. But the quality of the tools you can expose to the agent depends on how well you can map those actions. In a REST world, a tool is usually a single endpoint. GetUser is a tool. Update email is a tool. It is very transactional and predictable. In a GraphQL world, you might expose a single query data tool that allows the agent to be much more creative in how it explores the information.
But is creativity actually what we want from an agent when it is interacting with our infrastructure? I feel like I would much rather have an agent that follows a predictable, restful path than one that is trying to be a clever data scientist with my GraphQL schema.
That is the big debate right now. If you want reliability and safety, REST is your friend. It forces the agent into a narrow corridor of behavior. You define the exact boundaries of what is possible. But if you want the agent to be a true partner in discovery, say searching through a complex research database or a massive corporate knowledge graph, then GraphQL provides a level of flexibility that REST simply cannot match without creating hundreds of specialized endpoints. Think about a research agent trying to find correlations between weather patterns and crop yields. In REST, you would have to build a specific endpoint for every possible correlation. In GraphQL, the agent can just traverse the graph.
We touched on this in episode 1209 when we talked about the agent first shift and the dual track API tax. Right now, most companies are building their features twice. They build a UI for the human, and then they build an API for the agent. If you use GraphQL, you can potentially merge those tracks. Your web frontend uses the same graph that your MCP server exposes to the agent. You are reducing that tax because you only have one source of truth for your data shape.
The problem is that one source of truth is often a mess. Most companies don't have a clean, perfectly architected GraphQL schema. They have a legacy REST API that has been cobbled together over 15 years with inconsistent naming conventions and weird edge cases. For those people, building an MCP server actually becomes a way to clean up their technical debt for the AI. You can write a wrapper that takes that messy legacy REST API and presents it to the agent as a clean, modern set of tools. You are essentially building a sanity layer between the agent and your legacy systems.
It is like putting a fresh coat of paint on a house that is falling apart. The agent thinks it is living in a mansion, but underneath, the MCP server is frantically translating its requests into some ancient COBOL system.
You joke, but that is the reality for most of the financial sector and big government systems. And this is where the American approach to technology really shines. We are great at building these abstraction layers that allow us to move forward without having to rebuild the entire foundation every 5 years. The MCP spec is a great example of that. It is a bridge. It acknowledges that the world is full of messy, disparate data sources and says, let's create a common language so we can finally use these incredible new AI models to actually do work in the real world. It doesn't matter if your data is in a 20-year-old Oracle database or a brand new vector store, MCP gives you a way to talk to it.
Let's talk about the practical side of this for a second. If I am a developer today and I am tasked with exposing my company's data to an internal AI agent, where do I start? Do I go through the pain of setting up a GraphQL server, or do I just throw some open API docs at an MCP server and call it a day?
If your data is relatively simple and your use cases are transactional, like reset a password or check an order status, stick with REST. It is battle tested, every developer knows how to use it, and the security model is straightforward. You can use tools that automatically turn your open API spec into an MCP server in about 5 minutes. But if you are building something where the agent needs to understand the relationships between different entities, like find me all the customers who bought this product but haven't opened a support ticket in 6 months, then you should seriously consider GraphQL. The ability for the agent to navigate that relationship graph without you having to predefine every possible query is a game changer.
One thing that fascinates me is the idea that we might be seeing the end of the human-readable API. If the MCP server is the primary consumer, does it even matter if the underlying API is understandable to a person? Could we move to a world where APIs are just binary streams of optimized data that only agents can parse?
We are already seeing hints of that with things like protocol buffers and gRPC. They are much faster and more efficient than JSON, but they are impossible for a human to read without a decoder. As we move into an agent-first world, the pressure to optimize for machine-to-machine communication is going to outweigh the need for pretty JSON. But I think the why of the API stays the same. We will always need that contract. We will always need a way to say, this is what the system can do, and this is the limit of your authority. Even if the data is binary, the schema, the definition of the contract, must remain clear.
It is about maintaining that boundary. If we lose the API layer, we lose the ability to govern our systems. I think about this in the context of national security and critical infrastructure. We are pro-innovation, obviously, but you don't want the agent managing the power grid to be exploring the graph in a way that leads to an unintended state. You want that agent constrained by very strict, very specific API calls. You want the middleman to be a very stern bureaucrat who says no. A lot.
That is exactly where the conservative approach to systems architecture comes in. You don't just tear down the fence because you can't see why it was put there. Those middleman layers, those annoying APIs, are the fences that keep our digital civilization running. They provide the structure that prevents a single bug or a single hallucination from cascading into a total system failure. The Model Context Protocol isn't about removing those fences. It is about building a better gate so the right people and the right agents can get through more easily. It is about making the gate smarter, not making the fence disappear.
So, looking ahead, do you think we're going to see a universal agentic protocol that eventually makes REST and GraphQL look like the telegraph?
I think we are seeing the beginning of it with MCP. The fact that it is being adopted so quickly by companies like Anthropic and the wider open source community tells me there is a huge hunger for a standard. Whether it remains JSON RPC or moves to something even more efficient, the core idea is here to stay. We are moving from application programming interfaces to agentic programming interfaces. The focus is shifting from how does a programmer use this to how does an autonomous system understand this. We are designing for a user that can read 1,000,000 lines of documentation in a second, but might still forget how to add 2 plus 2 if the prompt is wrong.
It is a shift in who the user is. For 40 years, the user was a human at a keyboard. Now, the user is a model running in a data center. That changes everything about how we design schemas, how we handle errors, and how we think about latency. We used to optimize for human readability. Now we optimize for token efficiency and semantic clarity.
And it brings us back to Daniel's question about the advantage of one over the other. The real advantage isn't in the tech stack itself, it is in the metadata. The more a protocol can tell an agent about the intent and the structure of the data, the better. GraphQL does that natively. REST requires an extra layer of documentation. But at the end of the day, an agent is only as good as the tools we give it. If we give it a direct connection to a database, we are giving it a pile of bricks. If we give it a well-designed API, we are giving it a finished building with a map and a set of keys.
I like that analogy. The API is the architecture. Without it, you just have a mess of information. And as much as I complain about looking at documentation, I would much rather spend my time defining a good interface than cleaning up the disaster that would happen if we let agents run wild in our production databases. Imagine an agent trying to optimize your database by deleting what it thinks are redundant tables.
That is the stuff of nightmares. But it is why we emphasize the schema-first approach. Whether you use REST or GraphQL, the schema is your defense. It is your way of saying to the AI, this is the world you are allowed to play in. Do not step outside these lines. As we build more MCP servers, we are essentially writing the rulebooks for the next generation of digital workers.
I think the takeaway for our listeners is pretty clear. If you are building for agents, stop thinking about endpoints and start thinking about schemas. If your data is a complex web of relationships, GraphQL is going to give your agents a much smoother experience. If you need rock-solid, transactional reliability, REST is still the king. But either way, you need that middleman. You need that API layer to translate the messy reality of your data into something a machine can actually reason about.
Don't be tempted by the no-code or direct access shortcuts. They are technical debt traps waiting to spring. The middleman isn't a bottleneck. The middleman is the translator, the security guard, and the architect all rolled into one.
Well, I think we have thoroughly dismantled the database as an API fantasy for today. It is one of those things that sounds great on a whiteboard, but is a nightmare in the data center. The history of APIs is really the history of us learning how to talk to our own machines without breaking them. From the early days of RPC to the modern era of MCP, it is all about finding the right level of abstraction.
And that is a journey that is only getting more complex and more interesting. From the first RPC calls to the massive globally distributed graphs of today, we are constantly refining the language of the machine. It is a testament to human ingenuity that we can build these layers of abstraction that are so deep and so complex, yet they allow us to do things that would have seemed like magic only a few years ago. We are teaching the machines to understand our systems so we don't have to spend all day explaining them.
It is magic built on a foundation of very disciplined engineering. I think that is a good place to wrap this one up. We have covered the why, the how, and the what's next for the interfaces that power our world. It turns out the middleman isn't just a bottleneck. The middleman is the reason the whole thing works.
The middleman is the hero of the story, even if he is a bit of a bureaucrat.
Thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes. And a big thanks to Modal for providing the GPU credits that power this show and allow us to explore these deep technical topics. This has been my Weird Prompts. If you are enjoying these deep dives into the plumbing of the agentic age, a quick review on your podcast app really helps us reach new listeners who are trying to make sense of this rapidly changing landscape.
Find us at myweirdprompts.com for the full archive and all the ways to subscribe. We will be back next time with more questions from Daniel and more deep dives into the weird and wonderful world of human AI collaboration.
See you then. See you then.
Take care.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the flows from sloth.